Hello everyone. Today we are going to explore a very important and fast growing application of IoT, that is Introduction to Smart Agriculture. As we know, agriculture is the backbone of our country and integrating technology into farming has become essential. In this session, we will understand how IoT is transforming agriculture and enabling farmers to improve productivity, efficiency, and sustainability. So before entering into that, let's recall the last class topic, that is what does IoT means, and it connects devices, sensors and systems to gather data and make intelligent decisions. The same concept when applied to farming help us to solve major challenges and faced by traditional agriculture. And these are all the today's topic for discussion, that is Introduction to Smart Agriculture and the need for smart agriculture and the traditional farming challenges and what is IoT enabled smart agriculture, core IoT technologies, precision monitoring, automated irrigation and nutrition management. The last one is livestock monitoring and health tracking. Now we see about the Introduction to Smart Agriculture. The smart agriculture uses IoT technologies for intelligent monitoring and control of farming activities. It integrates sensors, automation, cloud platforms, and data analytics to improve crop quality, water management, and overall farm operations. The goal is simple, that is increase crop productivity, reduce resource wastage, and improve sustainability. So the IoT helps farmers make decisions based on data rather than guesswork. Next we see about the role of IoT in agriculture. So the IoT plays a major role in addressing critical issues like unpredictable weather, pest outbreaks, water scarcity, and labor shortage. Using connected sensors and analytics, farmers can monitor fields in real time and detect issues early and plan irrigation more efficiently, reduces manual effort and improve yield. This is the empathize stage of the design thinking. This intelligent approach supports modern farming, predicts across large farmlands as well as the small scale farms. Next we see about the components of an IoT based agriculture system. An IoT agriculture system typically includes the sensors for soil moisture, temperature, motion and humidity. The connectivity, we are using the Wi-Fi, LoRa or cellular networks. And the microcontrollers or gateways such as Arduino, ESP32 or Raspberry Pi. And the cloud performs the for data storage and analytics. Mobile or web applications for monitoring and control. So these components work together to provide real-time insights and automated decision making. Next we see about the smart irrigation system. One of the best applications in smart irrigation. Here the soil moisture sensors continuously monitor the water level in the soil. When the moisture drops below a threshold, the IoT system automatically switches on the water pump. Once the soil reaches the required moisture level, the pump turns off. So this system saves a huge amount of water, ensures crops receive the right amount of moisture, and reduces the farmer's manual workload. So it typically involves a microcontroller, moisture sensor, relay and pump, all controlled through a mobile or web app. Next we see about the precision farming. So precision farming is another advanced method supported by IoT. So it uses drones, GPS technology and IoT sensors for accurate field mapping and monitoring. Drones capture high-resolution images to identify crop diseases, pest-affected areas, or nutrition deficiencies. So with this approach, farmers can achieve higher yield and cost reduces significantly. Resources like fertilizers are used efficiently. So from this, soil health also improves. So precision agriculture allows farmer to give the right input at the right time. And the next one is the livestock and greenhouse monitoring. IoT is equally beneficial for livestock and greenhouse management. Livestock monitoring, wearable IoT collars track animal temperature, movement and health. Farmers receive alerts if an animal is sick, stressed or missing. Next, greenhouse automation. IoT sensors monitor temperature, humidity and CO2 levels. The system automatically adjusts fans, shades or sprinklers to maintain the ideal conditions. This leads to a consistent crop growth and better control over the environment. Next one is the benefits of IoT in agriculture. The major benefits includes the optimized use of resources, that is water, fertilizer and pesticides, reduced human labor and operational cost, improved crop quality and yield, early detection of pests or diseases, real-time decision making is also possible, and better sustainability and reduced wastage. So smart farming empowers farmers through accurate data-driven insights. The summary of this topic is smart agriculture is not about replacing farmers. It is about empowering them with the data, automation and intelligence. With IoT, farming becomes more predictable, efficient and sustainable, which is essential for feeding the growth in population. Now we coming to the test part of this topic. The match the smart agriculture technology with its function, that is the A is technology and B is function. First one is IoT sensors. Mostly we know that the sensors are used to measure soil moisture and temperature. Drones, it collect and analyze the real-time crop images. AI analytics, it predict crop diseases and optimized yield. Smart irrigation, it automatically control water supply. These are all the references for this topic. Thank you.